we're going to take a look at function composition. Functions are concepts that are both pretty easy to understand and pretty hard. The idea of what a function is that you are taking some value of x and you're performing some operation on it. We write a function like this, f of x, and I'm going to let f of x equal x plus 2. And I'm going to let g of x, another function, equal 5x. Now, to find the composition of functions, there's different ways to write it. One way is to say f of g of x, and that's a little circle in there. Personally, that's not my favorite way to write it. I like to write it like this, f of g of x. And that helps me see what I'm really doing. What I'm doing is I'm replacing this x with g of x. So whatever's in these parentheses here, that's what goes in for x into our function. So f of g of x equals, and the way to think about it, the way to do this is f of g of x. F is the outside function. So start by thinking of this function. This function is x plus 2. So I'm going to write, this is not the answer yet. This is not even correct what I'm about to write. But I'm going to write f of x over again. X plus 2. Now, everywhere I see an x, I'm going to replace it with g of x. So I'm going to take this g of x and put it in for x. So that's what I'm going to do. So I'm going to erase this x, and I'm going to put in instead g of x. And so g of x here was 5x, so I'm going to put 5x right there. So that's f of g of x. Okay, let's try another one that's going to be a little bit more tricky, not much. Okay, so this time I'm going to have f of x equals 3x plus 2, and g of x equals 7x. And this time I want to find, this time I'm going to do g of f of x. Okay, g is my outside function. So I'm going to start by writing g of x. G of x is 7x. And now everywhere in here, everywhere I see an x, I'm going to replace that x with f of x. So I'm going to take f of x and put that in for x. So I'll erase my x, and I'm going to put in f of x. Now I have to be careful. There was an implied multiplication here. So when I put in f of x, I need to put it in parentheses because my original g of x, 7, was multiplied by x. So my 7 needs to be multiplied by my entire f of x here. And I need to use the distributive property now to get 21x plus 14. And so that equals g of f of x. Okay, let's try one that's a little bit harder. Okay, this time let's have f of x equal 2x squared plus 3x, and g of x equals x plus 1. Well, this one is actually considerably harder. So I'm going to find now f of g of x. Okay, remember, I start by writing my outside function. My outside function is f. So I'm going to write my outside function. But wherever I have an x, I'm going to leave a big space because I'm going to have to replace the x with g of x, because this is f is the function, this is f written with an x in it. But I need to write f with a g of x in it. Okay, so I'm going to start by writing my outside function, which is 2x squared, and I'm just going to leave a space here, plus 3x. That's my outside function. And now everywhere I see an x, I need to replace that x with g of x. So I'm going to replace all of my x's with g of x's. Now what I'm going to do is I'm just going to erase my x, not anything else. So just the x. I'm going to erase the x and put in x plus 1. So I'm going to erase this x, and I'll put in x plus 1 in parentheses. I need to be careful every time I put it in parentheses. And now I'll erase this x, and I'll put in x plus 1. Notice that squared is still there. That's really important. The squared was here, the x was squared. Now I'm going to have an x plus 1 squared. Now I'll multiply this out. So x plus 1 squared, I have to rewrite that as x plus 1 times x plus 1. I cannot just square each thing inside. I have to write it out like this. And then I'm going to distribute the 3 to get 3x plus 3. Now, to multiply these two binomials, I have to distribute each term or FOIL it. So the first, I multiply those together. X times x is x squared. Now the outer, x times 1, x times positive 1 is just plus x. Now the inner, that's plus x. And the last, that's plus 1. And then plus 3x plus 3. Now I'll combine my like terms, 2x squared, my like terms are x and x, so plus 2x plus 1, and then plus 3x plus 3. Now I need to distribute this 2, so I'll get 2x squared plus 4x plus 2 plus 3x plus 3. Finally, I'll combine all of my like terms. My 2x squared is my only x squared term, so I'll get 2x squared. I have a 4x and a 3x, so plus 7x. And I have a 2 and a 3, so plus 5. Okay, so that's a fairly complicated composition of functions because I had to do a lot here. Now let's look at some others that have a little bit more tricky functions that we're going to be working with. So let's take a look at if I had my f of x equals 3x to the negative 1 and my g of x equals 2x minus 1. Okay, and this time let's start by finding f of x. Okay, so that one's a little different. F of x. Okay, so our outside function is f. So I'll start just by writing my outside function, 3x to the minus 1. And then everywhere I have an x, I have to replace it with f of x. Okay, so what's f of x? This is f of x. So wherever I have an x here, I have to replace it with f of x. So I'll erase my x, and then I have to put in f of x. Now remember, whenever I do this step, I put it in parentheses. So I'll have 3x to the negative 1, and that 3x to the negative 1 is still raised to the negative 1 power. Okay, now I have to remember, what does a negative 1 power mean? A negative 1 power means that it's going to go into the denominator. Now if it was negative 2, it would go into the denominator and be squared. If it was negative 3, it would go into the denominator and be cubed. Negative 1 just means it goes into the denominator. So I now have 3 over 3x to the minus 1. Now this 3x to the minus 1 came because I had 3x to the minus 1 to the minus 1. So this 3x to the minus 1 had to go into the denominator. But now I still have this negative exponent. Negative exponents are really not a good thing to leave in your answer. Okay, now I have a negative x to the negative 1, but it's in the denominator. What that means is if you have a negative exponent in the denominator, then it has to go in the numerator. So a negative exponent in the numerator goes to the denominator, a negative exponent in the denominator goes to the numerator. So this becomes 3 over 3, but the x to the negative 1 goes to the numerator, so it becomes x. Okay, there's one more step I can do here. I can cancel out these 3's, and I just get x. Okay, so that was f of x. Okay, now let's see how we would do f of g of x. So that's the one we're going to do next. Okay, I start by writing my outside function, which is 3x to the negative 1. Now I'm going to erase this x and replace it with g of x. So I erase the x, and I replace it with g of x, remembering to keep the g of x in parentheses, so 2x minus 1 to the negative 1. Now I have this negative 1 exponent again. Remember what that means is you take this and you put it in the denominator. So this will be 3 over 2x minus 1. And that's the end of that. We can't simplify that one any further. Okay, so now let's take a look at what g of f of x would look like. So we're going to do g of f of x instead of f of x of f of x or f of g of x. So we're going to do that. Okay, so I'll take now, I want to do g of f of x. So g of f of x. Okay, I start by writing my outside function, which is 2x. And whenever I write an x, I'll just leave a little space because I know I'm going to erase it. Then I erase that x, and I replace it I'm going to replace the x with f of x, and I'm going to put it in parentheses, 3x to the negative 1. Okay, so I put that in parentheses. Now I simplify. I can multiply, I always can multiply coefficients together. So 2 times 3x to the negative 1 will just be 6x to the negative 1 minus 1. Now remember, this negative 1 exponent means this x really belongs in the denominator, and it becomes 6 over x minus 1. Okay, so now let's try another one. Okay, this time we'll have f of x equals 4x to the negative 5th and g of x equals x to the 3/4. And I'm going to find, let's find f of g of x. Okay, so I'll start by writing f of x. That's this. So 4x, and I just write this over here to give myself some more room, x to the negative 5th. Now, because this is f of g of x, I have to replace every x I have in here with g of x. So I'm going to erase my x, and I'm going to put in parentheses, what g of x is. This is what g of x is. Okay, now I have to remember how to simplify this. And when you raise a power to a power, you multiply exponents. So this now becomes x to the 3/4 times negative 5. Well, that's the same as negative 5 over 1. And remember, when you multiply fractions, you just multiply the numerators, negative 15, and multiply the denominators, 4. Okay, well, let's simplify this a little bit more. Since this is a negative exponent, we're going to take this to the denominator, so it will be 4 over x to the 15/4. Now notice, when I took it to the denominator, this is no longer negative, it's now positive. And so when you move a negative exponent to the denominator, it becomes positive. If you had a negative exponent already in the denominator and you moved it to the numerator, it would also become positive. Now, there's not really, there are different ways that you could write this, but just to remind ourselves, what does this actually mean? What this means is the 4th root of x to the 15. That's what that really means. Now, if we really wanted to, we could rationalize this denominator, but I'm just not going to do that. Okay, let's try one more. And this will be our last one. Let's have the same f of x. So f of x equals 4x to the negative 5th. And I'm going to find f of x. Okay, I'm going to start by writing my outside function, which is f of x. So I'll have 4x, and I'm just going to write this up here to give myself enough room, negative 5. I'm going to erase my x, and I'm going to replace it with f of x, the whole f of x, which is 4x to the negative 5th in parentheses. So 4x to the negative 5th in parentheses. Okay, so now we have to simplify this. Okay, this is not fun to simplify, but I'll start by looking inside the parentheses. Only the x is raised to the negative fifth, not the 4. So the 4 stays where it is, and the x to the fifth goes to the denominator. And notice when it went to the denominator, the negative turned into the positive. Okay, now I need to take this whole 4x to the fifth, 4 over x to the fifth, and make it to the negative fifth. Okay, so what that does is I'm going to make this 4 to the negative fifth over x to the negative 25th. Because when you raise a power to a power, you multiply exponents. And so this is really 4 to the 1. So 4 to the 1 to the negative fifth is 4 to the negative fifth. X to the fifth to the negative fifth is x to the negative 25th. Okay, now let's simplify that a little bit more. This 4 stays the same. These both have negative exponents. So this was in the numerator. The negative exponent means it needs to be in the denominator. This negative exponent was in the denominator. That means it needs to go into the numerator. And when we do that, the negative exponent then becomes positive. Now there's one more step we can take. Here I have 4, and that's like 4 over 1 times x to the 25th over 4 to the 5th. I can cancel this 4 with one of these 4s. And then I'm left with my final answer, which is x to the 25th over 4 to the 4th, or x to the 25th over, oh boy, what's 4 to the 4th? Okay, 4 squared is 16, 4 to the 3rd is 64. 64 times 4, 16 carry the, oh, I knew that, 256 over 256. Okay, so that's our answer there.